Okay, passenger at an airport pulls travel case as shown. When the passenger is stationary, a free body diagram corffrydd, for the travel case is shown below. It is held at rest by the passenger's hand at H and its centre of gravity is at G. The mass of the case is 8.5 kilograms. Cofiwch na mass ydy hwnna, dim grym. A mae gennym ni diagram yma'n dangos pellteroedd, gennym ni 70 cm o ddiwrth colin from the pivot, 70 centimetres, and we also have 12 centimetres for the weight. Diffiniad ydy'r peth cynta. The first question is definition, which you can get from your definitions list. Cyfrifwch beth yw maint y tyniad pull tuag at I fyny F gan y llaw ar y ces. Calculate the size of the upward pull F of the hand on the case. Right, so gyda ni moment clockwise. Clockwise moment is due to the weight, G. And hwnna yn 12 centimetre, 0.12 metres, times G. Os da ni'n galw G yn, we'll label the force as G, which is 0.12 times 8.5 times 9.81, and that gives us nearly exactly 10 newtons, 10 newton meters. And with the moment gwrth-clockwise, the anti-clockwise moment will be equal to the clockwise moment. Felly mi fydd o yn dim 0.7, 0.7 meters, this distance here, times F, and that is equal to 10 newton meters. Therefore, F is 10 over 0.7, which is 14.3 newtons to 3 sig pigs. Okay, wedyn, os da ni'n ail-bacio'r ces fel bod y craidd disgyrchiant yn bellach o'r olwyn, so now we move the centre of gravity further away from the wheel. How would that affect the size of force F? Well, if we move G to the right, that would increase the clockwise moment. Therefore, the anti-clockwise moment needs to increase. Ag gan bod y pellar yn stuck ar 70 centimetres, 0.7 meters, we can't increase the distance, so F has to increase to balance. Okay, the second part of the question is basically simultaneous equations. Gynnwch chi hafaliadau cydamserol fydd yn digwydd yma. So the passenger now walks at 1.4 meters per second onto a walkway of length d meters, which is itself moving at 0.8 meters a second. At the instant she steps on the walkway, another passenger initially alongside decides not to take the walkway, but instead walks alongside it at a speed of 1.5 meters a second. The passenger on the walkway takes a time t to reach the end. The passenger walking alongside takes an additional 14 seconds before reaching the end of the walkway. Right. We want to write an expression for the distance d travelled by the passenger on the walkway, first of all. Okay, felly da ni isio hon yma. Want a v total, os liciwch chi, total velocity is going to be 1.4 plus 0.8, 2.2 meters a second. And we know that v is distance over time, with new symbols then. Okay, so d is the length travelled by the young lady, and t is the time taken. So we need an expression for D is V times T, which in her case is 2.2 T. Your boy, the man walking alongside, he takes an additional 14 seconds before reaching the end. So D for him is going to be his velocity, 1.5 meters a second times T plus 14. Adam yn iwan efo'r hafaliadau cydamserol. We've got two simultaneous equations in terms of D and T. So if we rearrange the first one, I, we can get an expression for time. T is D over 2.2. And we place that expression in II. Felly mae gennym ni D equals 1.5 D over 2.2 plus 14. Mae hwnna'n symleiddio i... rearranging, we have D minus 1.5 over 2.2 D is equal to 1.5 times 14. That's 21. So I'm going to need, if we do this sum here, 1 minus 1.5 over 2.2, we get 7 over 22. D is equal to 21. D is 22 times 21 all over 7, which gives us annual mass. That gives us 66 meters.